right, so now that we have all this data, how would you make it accessible to others who might need it and in a consistent manner? I'm just thinking about all this very active parts data flying all over the place.
That's a great question. And to answer it, let's focus on inventory management setup. This car company has a global network of certified repair shops that make frequent requests for different replacement parts. They all use an app that queries stock levels, places orders, and so on. This means they have thousands of concurrent requests per second. To make sure they can serve all this data in real time and ensure transactional consistency, they use Cloudera Operational Database. It's their singular source of truth of global parts availability at any given moment. Let's jump to our next demo to learn more.
Hello, my name is Alex Lee. I am the Solutions Engineering Manager for Enterprise West here at Cloudera. I am going to walk through a demo of how to use Cloudera's Operational Database, aka COD, as a backend database for a parts inventory application. In this scenario, the application will be used by dealers and garages around the world. The key requirements are to 1. Show the current level of inventory for parts being created by any of 5 factories making the parts, and 2. Allow purchasers to request and return parts. This application needs to accurately show up-to-date availability information per each transaction. In other words, despite high levels of read and write concurrency, we need transactional consistency. You will hear the details of COD in the session following this demo. And while this demo is fairly simple, please keep in mind that this technology is already part of our core platform and is already running mission-critical applications in many of the biggest companies out there. One of the major innovations of COD is that we take away the administrative overhead, such as installation, configuration, tuning, and scaling. This demo is broken into 2 parts. So first, I will show how we can easily provision our operational database. We will then look at a simple demo application that uses COD as its system of record to show how buyers can order parts based upon up-to-date availability information. First, let's look at provisioning. From our home screen, we go to Operational Database. To create the database, click on the Create Database action. You select an environment. This is where SDX lives, all the security, governance, and metadata in a common layer that all the compute can talk to. We will actually use Cloudera Machine Learning to write the front-end application, so you'll see how easy it is to connect the two since they are part of the same SDX. You give the database a name and click Create Database. This takes about 20 minutes, so we won't click on this now. But if you look over here, we see one that has already been made to host our data. So that's how easy it is to provision our operational database. In the past, you would need a static cluster of servers. You would need to install and configure the OS, install and configure our software, and then tune the operational database for your environment. Also, if you needed additional capacity, scaling was a manual process following those same steps. Here, we have taken care of all of that for you. In this Connect tab, we have information we need to connect to the database using various methods. Note also that Kerberos has already been set up for us. And in our case, we're using the Phoenix Thin Client. Phoenix is a SQL layer on top of our NoSQL engine. And this URL is what we'll need to connect to the database. We'll see this later in the application code. We also have some charts that show various performance metrics, such as throughput, latency, and concurrency. For now, I'll open up Hue in a different tab so we can look at the data. But before we do that, let's review how we ingested the data to begin with. As you recall, we used Apache NiFi to pull data from the 5 different factories creating the parts. As a part is created, a record is sent to a Kafka topic. We then pull data from those Kafka topics, enrich each row with a timestamp, and write that data to our operational database. Again, each part is a separate row that we store into the inventory table. Going to Hue, we can take a look at that inventory table and see what that data looks like. We see that for the various factories, we're creating different parts and adding them as a row to the table. Now let's go to the application. Again, this was written using Cloudera machine learning, and although there is no machine learning in this demo, it is still a very easy place to build and deploy applications. From our project, we can look at the hosted applications. From this website, I can reserve parts that I need. So let's take a look at this part C42CLDR. We see there's a little over 14,300 parts. So I can go ahead and order 2,300 of this part number, and you'll see that the database, once the request has been successfully processed, updates its quantity to remove the amount that I requested. I can go ahead and request 8,000 more of these parts, and again, you'll see the database being updated. If I try to request too many, I'll get an error that there's not enough inventory. And I can also use this interface to return parts using a negative value. So again, you'll see that this quantity has been updated. Lastly, let's take a quick look at the application code. This is a Flask application that lets you make API calls from the front end that run as these different Python functions. So we can take a look at get parts. As you can see, it does a select against the inventory table and lists out the different parts as well as a count star of all of those individual parts. It then fetches the data into a JSON file, formats it, and returns it back to the application. We can also look at how we connect to the database. You'll see that we need authorization information as well as the URL. That URL was the one that we had seen earlier in the Connect tab for our thin client. So that's what I had to show. Again, Cloudera Operational Database is a great way to host applications with high concurrency and low latency requirements. And deploying this on Cloudera's data platform allows for easy integration with other parts of our platform.
My name is Krishna Maheshwari. I'm a product manager here at Cloudera, responsible for operational databases. Today, you saw a demo that talked to you about one specific use case of how operational database can be used. Fundamentally, Cloudera believes that you are interested in leveraging big data to improve your company's performance and increase its agility. And so we've designed the Cloudera Operational Database to help you with it. In the demo, you saw it took 3 clicks to create a database. Behind the scenes, it took 20 minutes to deploy it. That shaves off months of effort that were previously required with legacy databases to deploy and configure a database. In addition, this database is autonomous, which means it reduces a lot of effort from the administration. Specifically, it auto-scales, auto-tunes, and auto-heals. Auto-scaling ensures that you're always able to meet your application SLAs. It will scale up when there's greater demand, but then it will scale down, reducing costs when there isn't as much demand. It auto-tunes, You can't solve every problem by throwing hardware at it, and we recognize that. And the system will understand the workload and its characteristics and tune itself to improve performance over time. It also auto-heals, solving for many operational issues that used to plague folks in the past. From a development perspective, there are three big problems that application developers face when building or migrating applications. Let's talk about all three of them. First is selecting the database architecture. An application developer has to figure out, do they want to scale up or a scale out database? If it's scale up, how do they want to think about sharding and shard management when their data outgrows their database and they have to deploy multiple instances of it? And lastly, how do they want to think about risk domains and failure modes? Does it need to be resilient to hardware failure on one node? What about data center failure, regional failure, multi-regional failure, or maybe even cloud vendor failure? How do they make sure their applications keep on running? At Cloudera, we believe in eliminating complexity. There's simply no sizing required whatsoever. You just put load on it, and the database will scale to meet that load, whether that's scaling up or scaling down. There's also no shard management whatsoever. The system will automatically partition the data and move it around to keep the database balanced and performing optimally. Lastly, it's always HA out of the box. That means you no longer have to worry about hardware failure. And because this is in the cloud, it's also resilient to availability zone outage. That used to be data center outage in the on-prem world. We always deploy spanning 3 availability zones. And then if you want to be resilient to regional outages, we have a wizard-based configuration tool for replication that lets you set up active-active bidirectional replication between 2 different regions and ensure availability when a region goes down. The second biggest consideration is, do developers want to use a relational database or a non-relational one? Relational databases have been around for almost 50 years, and so all application developers are used to building applications with it and interacting with them within the context of their application code. Over the last decade, many different types of non-relational databases have also come out. Some of the big ones include wide column, key value, document, and graph. With these different modes come different interface languages. Does the application developer on your team want to use SQL, a SQL variant, JSON, or an API? And these can vary across each of these different databases. And lastly, how should the model of the database from a consistency perspective work? Most application developers are familiar with the relational world, which is strongly consistent. That means when they write something, it is immediately available to read. Or in other words, a read is guaranteed to return what was last written. Within Cloudera, we believe in preserving familiarity while providing optionality. Out of the box, we provide relational, wide column, and key value support. In addition, we are strongly consistent. So you are guaranteed correctness that you assume as an application developer. And lastly, we're standards compliant. That means we support ANSI SQL, Python DB API 2.0, etc. So you get exactly what you're used to, even though this is a scale-out RDBMS. And lastly, schema design. This is incredibly important if you're looking to migrate an application. You've got an existing table design, an entity relationship diagram, layers of relationships, foreign keys, primary keys, index design. You want to be able to bring all of these over while taking advantages of the new database. Thinking about that, and also how we can help you simplify design, Cloudera Operational Database supports star schema and evolutionary schema simultaneously. So you can bring over the work that you've already done, but then now you can also evolve it as the need may be without heavyweight application re-architecture. We also support things like secondary indexing, distributed cross-row, cross-table transactions, so that, again, we're preserving the familiarity that your application developers already know. From an operational perspective, we're focused on improving operational agility, and that starts with auto-configuration. When you start, you no longer have to configure the database. It comes up optimized for the hardware that it's running on, We're automatically setting up things like Kerberos, like caching, etc. And we're setting up resiliency. As I mentioned earlier, multiple availability zones is available out of the box. And we have an easy way to set up replication. So all of this reduces your effort and your time. Second, it's auto-scaling. Performance optimizing itself for your peak needs and not your average needs. In the past, what you had to do as an admin was make a decision. Do you deploy a database based on the peak needs of your application and then have it underutilized for when that peak wasn't happening? Or do you set it up for the average need, knowing that you weren't going to meet your SLAs at peak workloads? That's now a thing of the past. We eliminate sizing and we automatically scale up and scale down as the need may be based on the workload that's happening. And lastly, it's auto-tuning. Things like hotspotting detection and space management can't be solved with auto-scaling. And so behind the scenes, if we notice hotspotting, we'll automatically redistribute the load to ensure you get the best performance possible, and eliminates the needs for things like region management and rebalancing as your data grows. Cloudera Operational Database is designed both for hybrid cloud as well as disaster recovery deployments, not just public cloud deployments. You already saw it takes 2 clicks to deploy a cluster. You have a wizard-based bidirectional real-time replication setup that not only spans clouds, but also lets you connect on-prem databases with cloud databases. So there is no management overhead for the thing you deployed in the cloud. You're still managing your on-prem infrastructure. You can move your applications from the location on-premise to the cloud across cloud regions because it's fundamentally the same database with the same client libraries. So whether you're doing lift and shift, setting up DR, or some form of hybrid cloud deployment, all of those are supported out of the box. Now let's walk through an example of star schema coexisting with evolutionary schema. In this case, we're going to create a database and a table using standard ANSI SQL. Create table with users and creating really an ID and an admin. So here we have an example of star schema along with evolutionary schema. We'll start by creating a table that has an ID and a user. We populated it with one and admin just to show you what this would look like. Now, if we wanted to layer an evolutionary schema, we can just insert into this, adding a column. State, which was not defined in the table, we just defined it on the fly. Taking it further, we can now create a view out of this, which means that as we write applications, we can almost treat this table or this version of the table that the rest of our application doesn't know about because it only dealt with ID and user. But now going forward, this is now the table definition we're moving forward with. And then at some future iteration, we can continue to evolve it, this time adding a column to both the table or the view without ever having to redefine either of those 2 original constructs. So this shows you how you can evolve your tables as your application needs grow, but you don't have to go back and change something you've already built. And for transactions, if you look at the SQL statements, they're both ANSI standards compliant. We support the upsert statement, MySQL supports inserts, but if you look at the highlighted portions, which are specifically around the transactions, the semantics are exactly the same. If you don't turn off auto commit, every statement is executed atomically on both databases. If you turn auto commit to false, then any number of statements won't be executed until the commit statement is executed. And at that point, all of those queries are done transactionally and atomically. It's the same, whether you're coming from MySQL or Postgres into operational database, the semantics are same, the way they work are simply the same. And in conclusion, what we showed you was that it's easy to develop against the Cloudera Operational Database. There is no sizing, it's multimodal, it's standards-based, and supports things like star and evolutionary schema. It's autonomous, so it auto-scales, auto-tunes, and auto-heals, eliminating management overhead. And it supports both multi-cloud deployments, on-prem deployments, and hybrid cloud, allowing you to move your database to wherever your company wants your data to be.